Yeah, see, I didn't see this room. There's a bunch of gauges left everywhere. Kept calling these 240, not sure if they're 240 or 120, but they're industrial style anyway. Could be wired for either. Oh, what is this? These are some really, really large meters. That's what they are, though. It's missing the plate in there that would tell you readings. It's missing markings, anyways. See down here, these are a couple more meters that are like those on the one panel inside. So this is like spare parts. Everything here is like spare parts or that sort of thing, or scrap, I'm not exactly sure. Synchronous converter. Is that actually a siren? It's hard to tell what some of this is when it's sitting up here. Chlorinator. So this is some of this stuff here. Stuff that's actually, it's like water treatment. These are indicator lights. See some of this stuff over here. I can get closer to it. Some of these meters are just absolutely huge. This has vacuum tubes on it. And there are these, which honestly I can't even tell you what those are. I'm not sure. Another meter here. How did the tape look down here?
Oh, that's interesting.
It's not even labeled anymore. This is like a presentation.
Give her your undivided and well-behaved attention. I'd appreciate it. Thank you. Yes, I know. Good morning. What they asked me to do is manage you guys some information on certified mechanics. And I'm sure that most of you have sat through wind services before and tell you about the proper lifting and the bend your knees and keep your back straight. We're just going to go with this one a little bit different angle. lot of little motions cause little stresses in there until the muscles fatigue. They give out. This guy's really hurt. He's gonna have trouble. But when you're in proper posture, if you're standing straight, then you should have 3 curves in your spine. Okay, you should have an inward curve through the low back, another outward curve in the mid part of your back, and then another smaller inward curve in the neck. Okay, now I'm just going to hold this guy by the pelvis. If you have these normal curves, so that you're straight up and down, then basically the spine is like a pile of blocks. It balances on itself.
Trying to tell if that was actually taken in this power plant. It could have been done. It could have been a presentation that was made here, honestly.
Your own posture.
Possible.
If you want to check your own posture, what you can do is just stand in front of a mirror, stand along the corner, just have someone look at you from the side. First thing you want to do is just get yourself standing as straight as you can. You don't want to start an exercise.
So yeah, this is like a live.
You don't have the muscle in the right
Yeah, you see
position.
nice egg up on the wall. This was filmed here.
And get the effect on the muscle that you want. Just get yourself standing as straight as you can. You don't want to start an exercise slouch. If you don't have the muscle in the right position, then you're certainly not going to do the stretch and get the effect on the muscle that you want. While you're doing the exercise, they're just little rules. The first thing you got to do is breathe. Okay? It sounds funny, but when people exercise, you tend to hold your breath. If you hold your breath, it signals your body that there's a certain amount of stress. The muscles are going to.
A bent claxons. Let's say federal. Yeah, federal signal. Electric horn. 125 volt DC. Some of these are gauges.
So yeah, this one you can see the inner workings of it. These were used to record data over time. Paper that goes around and it traces a line on the paper. And there's a lot of water in a power plant, and they might not want algae growing in the water.
Yeah, it's possible.
But I don't really know for sure.
Yeah. But you can see there's this tubing.
In the original plan, yeah, see, oh, there you go.
That's disconnected
So this would
tubing.
feed chlorine into the water supply.
Oh, you can see it up there.
It feeds it right in.
They even have a sign down there, danger chlorine. But it looks like this would be used as like an indicator. Water would go through there and you'd somehow...
Yeah.
It's like a level. I think it's measuring like the level or something though, because of the markings on
Right.
it.
It says pounds per 24 hours.
Oh.
So it's telling you a rate. There would have been tanks of chlorine gas standing upright along the wall. They would feed into this manifold here, which would feed over into that injector. And that's how they did it.
Wow.
Very
And this would,
dangerous.
yeah, and this would just be plugged in by an extension cord basically. This is just one of these actually, it's not a siren. The store does have pretty high clearance. Trying to figure out how tall it was. I actually see my breath in here. That's how cold it is.
Flooded.
Yeah.
Normally the stairs go down another 8 feet.
Oh, that's ice.
That's ice.
Wow. I wonder how many more levels down there actually are. If it's just one or... You can't see much down there. But this is actually... Like that light right there would actually be for next
Further
level down.
below.
Yeah.
So the floor is like another 5 or 6 feet below the water.
But see, this just looks like a...
The big conveyor belt.
Yeah.
And a motor to drive it.
See, at first I thought this was just like a little tunnel here, but that would actually be up at the ceiling of the...
Right.
Everything's been cut down here. They took out a ton of stuff. These panels are pretty big too. Oh, look. Another display or misplaced tape. And this one's unlabeled actually, so it could be blank. But somehow some of these KCA tapes and VHS tapes ended up down here. So this is almost like a, yeah, you can see the tracks are still in here. But this is like a pit for the rail cars. There's another lift up there.
Yeah. So the guys that worked in this part of the thing had their own showers.
Oh yeah. I figured there must have been another somewhere. Didn't seem like... Because you wouldn't go into the main building for that. The others are up there, the locker room.
Yep.
These mirrors got broken. It's like a towel dispenser, actually. I think. Oops. Still hangers in here. Posters. Like a pencil case or something down there.
This would have been a little clerk's office with their coal coming and going.
Yeah, there's a counter up here. Is that manual? Or would that...
I'm not sure how that worked. Looks like it's wired into something.
Well, you could manually turn it like that.
Hmm.
But I don't know. Probably would have been automated by something else.
Yeah. And then there's a pass through there that they could hand checks or something through. I don't know what that was for.
Here's an actual phone with the handset on it.
Yeah, there's
And that's actually a button for
Oh,
some purpose. Maybe
There's a
it could have
similar
been
one.
push to talk.
yeah, probably. There's a similar one over here.
Two in the same room.
Yeah, that one probably goes to the.
One of these said party line on it. But these are actually different than the one in the one room. Triple strip. So this is a desk. And these were actually plugged in too by a cord, the heater. Down here, here's a destroyed phone. This is the only standard phone I've seen throughout this whole place. All the others are some sort of unconventional setup. Is this a battery pack for something? Yeah, it is. Wow. Motorola battery pack.
Huh.
Could be for a two-way radio or something. If they had that. The store actually has an electronic lock on it. Oh, that one says open, close, or stop. Actually, I'm not sure what that's wired to, but this door is wired to something. A lot of different industrial buttons in here. This almost looks like a generator or something. Some sort of movable unit. Though I'm not exactly sure what that is. More filing cabinets back in here. These are stickers. Bunch of looks like another catalog right here. Or what is this? Okay, lab safety supply. It's amazing how the printing in these lasts very well. They all look freshly printed. Now this is like almost looks like a ledger book or something, but it's got different columns in it anyways. Bunch of cards. Looks like another very, very thin layer of ice here, and that's down to another pit. It's just flooded down there. Alright, this one looks playable, so we should insert it. Debris all over here.
Tip over. Another important part of a dozer is its blade. Bulldozers used in coal handling usually have curved blades. With a curved rather than straight blade, the blade is better able to scoop up and hold the coal without letting a lot of the coal spill away from the sides and top of the blade. Some bulldozers also have a device called a ripper. It's a tooth-like attachment that's used to rip apart frozen or tightly compacted coal before it's moved. The ripper and blade we just saw, as well as many other parts on a bulldozer, are often controlled and operated by hydraulic systems. We'll see how a typical bulldozer hydraulic system works. Move the blade. You're probably operating a hydraulic system. Since the hydraulic system is such an important part of the machine, we'll be taking a close look at bulldozer hydraulic systems in this segment.
Everything actually seems to be intact in here. And that's an unusual type of outlet. Okay. I actually have a phone in here. Push to page. Release to party. Huh. Look at all these lights too. Yeah, we kind of looked in this one before.
Oh, okay. Yeah, I guess I remember the boards on there.
And there's all these pipes that run out from here. They started dismantling them. That's like an insulator. Yeah, it's just a storage building. See, I was wondering if there were any vehicles left. If they even used this for vehicles, I don't think they did really. These are all old transformer parts. Well, the insulators on. I know, they got all banged up.
And that's the innards of a very big transformer. Coils.
Yeah. It's got a lock on it still. These are all pretty old ones. Yeah, this is the one I saw from inside there that just looks like it's, you can see it's just collapsing here. There are birds in here. Oh, so this was also the laundry room?
Well, it looks like the ceiling's all black.
Oh,
It's
gee.
like the primary part of. But somebody's been in here since the fire, so the papers weren't burned.
Of all the places, oh my gosh.
You see, that looks like the primary.
Thankfully, a building like this can survive arson to a large degree, but yeah, no, this had to be intentional. Yeah, you see some of these tape cases are melted.
So this is some kind of a projector, but that's all burned up.
Yeah, the whole thing is covered in.
It was pretty noxious, smoke.
Yeah, look at that. So there are some tapes that were lost, obviously. I mean, that's just reduced to goo.
Yeah.
I mean, look at this keyboard.
Right.
That looks so weird.
Now there's a tape, archive fast tape.
Is that for VHS or no? That's not VHS.
Yeah, something else.
I wonder if that's. It looks too narrow to be for the KCAs,
Probably those style.
but
right?
possibly.
Refrigerators.
Way down here. Now, of all the places, like,
Yeah, it ruined this thing too.
I'm not surprised.
The screen's off. The meter's broken.
There's a hot water tank. So that, yeah, he had some laundry stuff in here, but
But that's what they would have used for the cards.
see, I didn't know if they actually had any reading equipment left. What have we here? I honestly, oh, that's a tape player. That's the one tape player. Like, you gotta be kidding me. And then that's a monitor. Was it like a computer monitor though? It says NEC, SVGA. Could have been for one of the computers that would have had Windows 3.1 installed.
Yeah, it would have been VGA.
I don't think there were any TVs left in here. Or if they had, they must have had some at some point, but this actually says Ampex rather than RCA.
Yeah, so that's a data tape.
Oh, this is, yeah, but it's the same format, KCA 60. Wow. You just look up, take a look over here at the.
There's a bunch of tapes in the back that might have survived. I don't have nobody reading.
No, not that type. That would be a whole other. Somehow some of this got burned too.
This has a green wall. Do you think this is where they were doing that presentation?
No, they had green bricks like the one room we were just
that
in
green
down.
bricks?
No, like polished ones,
Oh.
like the other
Oh,
rooms.
the other type.
So it was one of the.
Downstairs.
Yeah, see, this got partially burned. Some of these papers survived. Oh, stash of tapes. No VHS in here though. That's all the records for. Circuit boards. Is this like another? It's a very large monitor. Very large monitor. See,
Yeah. I would probably been.
with a smaller one inside of it
Yeah,
that's all
too.
melted.
Yeah.
It looks like a computer monitor, but it's in scale.
Well, digital is a computer monitor.
Yeah. Nothing in here looks like a CRT TV.
Right.
Then see, this must have been a bunch of papers that burned. Wow.
There was obviously a flashover. The whole ceiling was hot.
That's nuts. And then here we have. It's hard to tell what I'm even looking at, the way these are melted.
Printer.
That's a printer, yeah. But this one does not look like a dot matrix, does it? Or,
Maybe I'm wrong. Maybe it's not a printer.
well, it's got some sort of paper feed thing here, I think. Possibly. But yeah, microfiche reader. Microfiche viewer. just ironic. All the rooms that could have burned, right? And then
Right.
we need a TV. Not like there is one, but mechanical maintenance.
That's a dot matrix printer there.
Yeah. Different style though. We got NEC keyboard. Looks like they used a lot of NEC computer
Yeah.
equipment. Is this a refrigerator?
Yeah, it was a refrigerator.
Wow.
So they had washer, dryer, refrigerator, sink.
Yeah, the old dryer takes it.
Repair shop. This is an office.
Didn't know this was here either. What's this suit? There's various things they put up here. And an air conditioner once again that vents into the
Right.
main building. Here we have another hybrid setup. Two types of outlets.
The year 2000 was the last calendar they got on.
Yeah. Once again, another catalog here. And
This is a computer circuit board.
yeah, there's another circuit board over here too.
Which part of some kind of a equipment there.
It looks like they're still wrapped like they're spare parts.
Yep. This must be where they worked on that stuff.
Okay, that is strange.
There's nothing.
It's just to get a bit of daylight from over there, but
I
the
suppose.
looks like that's all they left as far as that computer. There's just so many offices with paperwork left behind in here.
Yeah.
So I thought it was just those two areas. Yeah, so I took the lights off right here. This panel looks longer. There's actually a safety vest still here. This panel's still here. This one is not as rusted either. These are paper graphing devices that they use the round discs, and there were replacements for these or scraps of these out in the one storage room. Actually got fluid in there. This one has all sorts of gauges. Not sure, they probably were planning to take the whole thing out and they just haven't yet. Yeah. So this tunnel connects to one of the
The
other
other end
buildings.
of the coal tunnel. This is how the coal got into the building.
So this would have been around here. So that's like they zoned it, 'cause I'm noticing these are numbered. Yeah.
So you see this belt here, the coal would be traveling on this belt. All the way up to there, and it would be elevated to the roof.
So it's like they had a conveyor down here and then now they're up in the... up in the top. This is like the... looking at the ruins of the Titanic.
Right? Because they had old ship.
And this doesn't have ice over it. Wow. This is another siren, but it's different yet than what I've seen. And there are these all over.
For a generator to operate safely and efficiently, this heat has to be removed by auxiliary equipment. That's what we'll be talking about in this unit, generator cooling systems. Now, as an operator, it's your job to keep the generators in your plant operating within a certain range of temperatures. In this program, we'll look at different generator cooling systems and the auxiliary equipment that supports these systems. But let's start by examining why generators need to be cooled. The heat inside a generator comes from several contributing factors, such as bearing friction, fluid friction, and current flow. Current flow is by far the greatest factor. The more current produced by the generator, the greater the heat inside the generator. Most of the parts inside a generator can only withstand a certain amount of heat. Most insulation, for example, begins to break down above 120 degrees centigrade. If this were to happen, electrical faults may occur. So, the generator's operating temperature must be carefully and continuously monitored. One way in which heat can be removed from a generator is to draw or blow it out with air. In small generators, such as an exciter, that's exactly what happens. Air is drawn through these filters into the exciter. The filters prevent dust from getting into the exciter and contaminating its internal parts. Inside the exciter, air circulates around the moving parts, but for larger generators, air cooling is less practical because it's not a very efficient means of heat removal. There are other gases that provide much better cooling than air. For instance, large commercial generators use hydrogen. Hydrogen absorbs much more heat than an equal amount of air.
I think they did
So,
use hydrogen.
a generator can be cooled more efficiently with hydrogen. Certain concentrations. Hydrogen can explode at concentrations between 4 and 75% when mixed with air. The slightest spark can ignite the mixture when it's in this range. Below 4%, the mixture is too weak to ignite. Above 75%, there isn't enough air for the mixture to ignite. So, to maintain optimum efficiency and safety,
inside a hydrogen-cooled generator, the purity of the hydrogen is usually kept above 95%. The hydrogen is kept inside the generator casing by a special type of oil seal. We'll talk more about this seal in more detail
Maybe that's what they
later in
use
this
that
unit.
one oil.
We've seen up to this point
System
how
for.
generators can be cooled by using air or hydrogen. Since hydrogen-cooled AC generators are the most common type of generators you'll be working with, we'll focus on them for the remainder of this unit, hence attached to the rotor. The generator's field windings, or its stator, surrounds the rotor. The circulating fans push hydrogen through to the field windings. Hydrogen
Some of this is damaged.
moved. After being cooled, hydrogen is then recirculated back to the circulating fans, and the cycle repeats. So basically, it's a closed loop. Hydrogen absorbs heat produced by the generator and transports it to the coolers. From there, hydrogen is forced back into the rotor to begin the cycle over again. So far, we've looked at why heat is produced inside a generator and how air or hydrogen can be used to remove this heat. Before we look at auxiliary equipment that is used with a typical hydrogen-cooled generator, review the material in your text and ask your instructor to answer any questions you may have before we go on.
So this was a purchased training video. Would have been purchased probably with a course that was standardized. Oh geez. Something tells me a VHS tape isn't supposed to be white. Yeah, as if that isn't obvious. Look at that. That's worth a shot.
And evaporators are all heat exchangers, and they can help a plant operate at its maximum efficiency. In this unit, we're going to talk about some of the heat exchangers that you may encounter as an operator. In addition, we'll show you some of the procedures for operating plant auxiliary equipment.
Oh, that's why I was reading this.
Heat exchangers are devices that are designed to transfer heat from one fluid to another. In a plant, they're generally used to cool, heat, condense, or evaporate fluids. Heat exchangers operate by using the principles of heat transfer, and you probably already understand the principles of heat transfer. In order for heat to be transferred, there must be a temperature difference between two substances, and heat is always transferred from the higher temperature substance to the lower temperature substance. There are two ways in which heat is transferred in a heat exchanger. One of them is by conduction, the other is convection. Conduction is that process by which heat is transferred through a solid. Convection, on the other hand, is the process by which heat is transferred into a fluid. Now, there are two types of heat exchangers that we're going to be looking at in this unit. One is known as the indirect contact, or surface heat exchanger, as we'll call it. The other is direct contact heat exchanger. Indirect contact, or as we're going to call them, surface heat exchangers, transfer heat between two fluids that are separated by a solid surface, such as a tube. The two fluids differ in temperature, and heat is transferred from the higher temperature fluid through the solid surface into the lower temperature fluid. The way heat is transferred in a surface heat exchanger can be better understood by looking at a simplified illustration. This illustration shows a tube and two fluids. One of the fluids flows through the tube. The other flows on the outside of the tube. For our purposes, we'll say the fluid that flows on the outside of the tube has a higher temperature than the fluid in the tube. Now, let's focus in closer so that we can see what happens across the tube wall. Temperature difference between the two fluids causes heat to be transferred between them. Heat is transferred from the higher temperature fluid through the tube wall by conduction, and then into the lower temperature fluid by convection. Some surface heat exchangers are designed so that the fluid flow rate for one of the fluids can be adjusted. By adjusting the rate of flow, the amount of heat transfer can be controlled, and ultimately the temperature of the other fluid can also be controlled. Unlike surface heat exchangers, the fluids in a direct contact heat exchanger are not separated. They come in contact with each other. Therefore, in a direct contact heat exchanger, heat is transferred from the higher temperature fluid directly to the lower temperature fluid. As with surface heat exchangers, the flow rate and the temperature differential between the two fluids affect the amount of heat transfer in a direct contact heat exchanger. Well, we've shown you basically how heat is transferred in two types of heat exchangers. Heat exchanger. Now, all surface heat exchangers use two fluids that are physically separated by solid surfaces. Although the fluids for some surface heat exchangers are separated by metal plates, in the case of shell and tube heat exchangers, the solid surfaces are tubes. Inside the shell is a bundle of tubes through which one of the fluids passes. The fluid that passes through the tubes is called the tube side fluid. The other fluid passes through the shell on the outside of the tubes. This fluid is called the shell side fluid. The tube walls provide a surface for heat transfer between the two fluids. In this heat exchanger, tube sheets are located on either side of the tube bundle. Now, there are several ways in which shell and tube heat exchangers are classified. It is similar to the one we just saw. It also uses straight tubes with two water boxes. But, in this case, one of the water boxes is divided by a partition. The tube side fluid enters the inlet section of this water box, flows through these tubes, and into the other water box. The fluid flows back through these tubes and into the outlet section of the water box. It passes through the heat exchanger twice. The shell side fluid enters here, flows over the tubes, and exits here. It passes through the heat exchanger once. Because the tube side fluid passes the shell side fluid twice, it may be referred to as a two-pass shell and tube heat exchanger. U-tubes, on the other hand, are more difficult to clean because of their shape, so they aren't used as often in systems that have a lot of contaminant buildup. But in systems where a good deal of expansion and contraction occurs due to temperature changes, U-tubes are more desirable because the shape of the tubes allows for this expansion and contraction to occur. Also, in a U-tube heat exchanger, only a single tube sheet and water box are necessary. And an important part of your job as an operator will be to check the various shell and tube heat exchangers in your plant to make sure that they're operating correctly.
So. Yeah, that's what happened. I wonder why that one didn't want to play. Jeez. That's wonderful. Welcome to nothing. I don't know how they would get like that. You probably don't want to know. Okay. There's only one law I operate under. It's called Murphy's Law. Of all the things that could happen, the TV won't work. Oh, I didn't see this before. Huh. That's funny. Because I think I'm already following that guy. Whoever that is just followed me on Twitter recently. I did not even